Okay, so this is section 2.3, using Venn diagrams to study set operations. So our learning objectives is to illustrate a set statement involving two sets with a Venn diagram, illustrate set statements involving three sets with a Venn diagram, use Venn diagrams to decide if two sets are equal, use the Venn diagram to find the cardinality of the union of two sets. Okay, so when you start the diagrams involving intersections between two sets, region 1 represents the elements in set A that are not in set B. Region 2 represents the elements in both sets A and B. And 3 represents the elements that are in set B but not in set A. And of course, 4 represents the elements that are in the universal set that are in neither set A nor in set B. Now, illustrating a set statement with a Venn diagram, draw a Venn diagram for the sets with Roman numerals in each region. Using those Roman numerals, list the regions described by each set. Find the set of numerals that correspond to the set given to the set statement and shade the areas corresponding to the sets. Okay, so draw a Venn diagram to illustrate the set of A union B not. So this is the way that we go through this is I go ahead and I write it out. So I'm going to write out that the universal set is, and I don't use Roman numerals because that's just too much work. I just use regular numbers. So I say 1, 2, 3, and 4. And when you put your Roman numerals or in your numbers, they have to be in the same way every single time. So then I say set A has numbers 1 and 2 in it. Set B has numbers 2 and 3. Okay, and those never change, so those are the same all the way. So the first thing I'm going to do is the union of A and B. So if I do the union of A and B, means I got to put A and B together, so that would be set 1, 2, and 3. And then if I want to do the not of that union, not of that set, so I want to do the not of this set, I say, well, what's not in that set? That would be letter or number 4. So then when I go to shade it, I would just shade where letter or number 4 is. So I would shade on the outside. So that's how I would draw the diagram, and that represents the A union B not. Okay. So we'll try another one. We'll do the intersection of A and B not. So again, I always start off the same way, write out the numbers. So I say that the universal set is 1, 2, 3, and 4. I say that set A is 1 and 2. Set B is 3 and 4. And so the first thing I have to do is the not B. So what would set not B be? So not B is, well, B is 3 and 4. So not B would be 1 and 2. So then I want to know what the intersection is between A and B. Not B, I'm sorry, not B. Oh, I did that wrong. I'm so sorry. Wait a minute. Okay, back the boat up. I apologize. This isn't right. I kept one that doesn't look right. So B would be 2 and 3. So let me go back up here, and not B would be 1 and 4. I apologize. And then so not B would be 1 and 4. So then what I would say is the intersection would be the 1. So then I would just shade where the 1 is located. All right, so hopefully I didn't goof you up too bad on that. All right, so now we're going to do it with 3 sets. So again, your numbers are always going to be 1, 2, 3, 4, 5, 6, 7, and 8. when you do that. Okay, so let's try one. So example 3, we're going to do one that is A is the intersection of B intersection C not. All right, so again, start with your universal set. 1, 2, 3, 4, 5, 6, 7, and 8. So set A has 1, 2, 4, and 5 in it. 1, 2, 4, and 5. Set B has 2, 3, 5, and 6 in it. So 2, 3, 5, and 6. Set C has 4, 5, 6, and 7 in it. 4, 5, 6, and 7. Okay, so remember, you always do your parentheses first, so you're going to do the intersection between B and C first, and then you get to do the not of it. So B and C. So B and C, what do they have in common? They have in common 5 and 6. Okay, so now what we got to do is do the not of that. So we want to include everything that's not in the intersection. So that would be 1, 2, 3, 4. 5 and 6 are in, so 7 and 8 are out. So I would do 7 and 8. Okay, so now what I want to do is I want to do the intersection of A with that. So A is 1, 2, 4, and 5. And I'm going to do the intersection with 1, 2, 3, 4, 7, and 8. So again, this is set A, and this is the intersection between the intersection of B and C not. Okay, so what are in both? So when I look at that, I look to see what's in both. I got a 1, I got a 2, I got a 4, I got a 1, 2, and a 4. So I would shade in where 1, 2, and 4 are. So I'm going to erase my circles here. So 1, 2, and 4. So I would shade here, here, and here. And that's what my shading would look like. And there you go. All right. So here are some that I took off Alex. So it says, here's a Venn diagram that says B, D, and the universal U. Shade the B, not D. So again, you're going to go 1, 2, 3, and 4. So set B is 1 and 2. Set D is 2 and 3. And of course, the universal set is 1, 2, 3, and 4. Okay, so you got to do the union of B and D first. So I got to put B and D together. B and D together first. So that would be 1, 2, and 3. So what is not in B and D? What have I not listed? Well, that would be set 4. So then I would shade where set 4 is, which is on the outside. All right, so let's do the next one. I think I've already done this one, but let's do it again. All right, so 1, 2, and 3. So again, A is 1 and 2. B is 2 and 3. So I need the intersection of A and not B. So if B is 2 and 3, not B would be 1 and 4. Okay, so what's not in B? So then I'm going to do the intersection between the two. So I'm going to do the intersection of A, which is 1 and 2, and not B. So what do they have in common? And they have 1 in common. So, oops, just the 1. So I would shade where just the 1 is at. Okay, I think the next one is some more examples. Yep. So I just have found over the years that students really struggle in this section. So I made sure that I included lots of examples. So 1, 2, 3, and 4. So set C would be 1 and 2. Set D would be 2 and 3. And of course, the universal is 1, 2, 3, and 4. I don't know if I can put that or not. I don't always put that because you can see that is a given. All right, so not C. So not C would be what's not in C. So C is 1 and 2. So what's not in C? Oops, not 2. We would say not in C would be 3 and 4. So now if I want to do the union, so I'm doing the union. So I'm doing not C, which is 3 and 4, and D, which is 2 and 3. I got to put the two together. So if I put the two together, I got 2, 3, and 4. So I'm going to shade where 2, 3, and 4 are. So I'm going to circle here, shade here, and then I'm going to shade on the outside of it. So the only part that I did not shade is where 1 is located. Okay. Next one, I'm going to do the intersection of B and C. So 1, 2, 3, 4. So B is 1 and 2. C is 2 and 3. And then your universal set. Okay, so not B. So I got to figure out not B first. So everything that is not in B. So B is 1 and 2. So not B would be 3 and 4. And not C. So C is 2 and 3. So not C would be 1 and 4. Okay, so now what is the intersection between those two? So the intersection between B, or not B, and not C would be that 4. So then I would shade on the outside. All right. Okay, so we're going to go to the next one, which is deciding if two sets are equals by using Venn diagrams. I tend to not necessarily use the Venn diagram with this. I just kind of do both of them and see if they match. So this is 3. So what I have to do first is I have to set them up. So remember, you got to think about your Venn diagram to figure out which numbers are in them. So probably not going to have a lot of room here, so I'm probably going to have to erase something. So this is my Venn diagram. And I need to remember 1, 2, 3, 4, 5, 6, 7, and 8. So of course my universal is 1 through 8. And set A is going to be, so this is A, B, and C. So set A is going to be 1, 2, 4, and 5. B is going to be 2, 3, 5, and 6. And C is going to be 4, 5, 6, and 7. Okay, so what I need to do is I'm going to do both of these. Do this one, and then I'll do the other one to see if I get the same numbers in those sets. So the first one, I have to start with the parentheses, which is A union B. So I got to put A and B together. So A is 1, 2, 4, and 5, and B is 2, 3, 5, and 6. So 1, 2, 3, 4, 5, and 6 would be the union of those two. And then what I have to do is do the intersection of that with C. Okay, so now remember C is 4, 5, 6, and 7. So what do they have in common? So what if I look to see what they have in common, I'm going to see that they have in common 4, 5, and 6. So I would say that the answer would be 4, 5, and 6. Hopefully you kind of understood what I did there. Okay, now on this one, what I have to do, I gotta do the other one and see if I get the same answer. So just changing colors here. So I'm gonna do this one. So I gotta do the intersection of A and C first. So what does A and C both have in it? So A is 1, 2, 4, 5. C is 4, 5, and 6, and 7. So the intersection of A and C would be 4 and 5. And I got to do the union with the intersection of B and C. So what does B and C both have in common? So B is 2, 3, 5, and 6, and C is 4, 5, 6, and 7. So it looks like they both have 5 and 6 in common. Okay, so now what I got to do is do the union of those two. So I got to put them together, and I get 4, 5, and 6. And so they do, in fact, equal. And if I was to shade it on the Venn diagram, I would shade it right here. So that just tells me that those two are equal because I get the same answer when I do the problem. Okay, example 9. Finding the cardinality of a union. So remember the cardinality is how many are in it. So draw a Venn diagram illustrating the steps below, then use the diagram to find the cardinality of A, B, A intersection B, and A union B. Okay, so I'm going to put them all in a Venn diagram first. So I'm going to draw the Venn diagram right here. Okay, so here's set A, and here's going to be set B. Okay, so the first thing when I do it, I don't know about you, but I like to find the intersection. So the intersection is going to be 6, 7, 8, and 9. Okay, I don't have room in that circle to put that, so I'm going to draw the circle better. So 6, 7, 8, and 9. Okay. Now 1 through 5 has to go out here. So 1, 2, 3, 4, and 5. And then 10, 11, 12 have to go here. Okay, so we have to find the cardinality of A and B. So how many numbers are in set A? So if I just count them up, I hope you realize there's 9 numbers, okay? Because I'm counting up 1 through 9 basically. And then if I do the cardinality of B, I'm going to say, okay, there's 1, 2, 3, 4, 5, 6, 7 numbers. Okay, how many are in their intersection? So how many are in their intersection? Well, that would be the 6, 7, 8, 9, so that would be 4 of them. In the union, remember to count up the union, you don't count them twice. So basically you're just counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So there's 12 of them. Okay. So what they want us to do is use the results to develop a formula for the cardinality of a union. So they want us to figure out how can we come up with 12 using the other numbers. So what I always like to do in class is I'll say, okay, so 12 equals, and then I've got to use the 9, the 7, and the 4. So I always ask my students, what arithmetic would I put between the 9 and the 7 and the 4 so that I could come up with 12. So 9, and then I got to get it above 12. I got to get it up there. So I'm going to add 7 to it. But 9 plus 7 is 16. But if I subtract it, I get the 4. Okay, so what we did is we just figured out the formula to find the cardinality of a union. So what we did is we found that the cardinality of the union of A and B is the cardinality of A plus the cardinality of B minus the intersection. And it kind of makes sense if you think about it this way, is there was 4 numbers on on the intersection. So when we added 9 and 7 together, we were counting those 4 numbers twice. So we had to subtract a group of them. So that's why we had to subtract the intersection. And there's the formula that we just came up with. Kind of cool. So now we're going to use it in a story problem. So in a survey of 100 randomly selected freshmen walking across campus, it turns out that 42 are taking math class, 51 of them are taking an English class, 12 are taking both, and how many students are either taking math or English? So we're looking for that union. So that's what we're looking for. So we're looking for the union. So I know that there are 51 taking English, or 42 are taking math. So I'm just going to say, I'm going to say N of M for math is 42. And I know that 51 are taking English, so I'll use E for English. And that are taking both is 12, so that would be the intersection. They'd be in both. So the intersection between math and English would be 12. And I'm trying to figure out what is the union between them. So I would say that it would be 42 plus 51 minus the 12 that are in both. So 42 plus 51 is 93, right? And 93 minus 12 would be 81. So 81 students are taking either math or English or both. All right, that's the end of that.